Okay, everyone, it's 11:30, so I'm going to get started with the lecture. Before I start, does any of you have any questions about anything? Everything's crystal clear? Okay, so first of all, I want again to make sure that you guys know that your exam, final exam, is not this Friday, the next Friday after that, which is like 17th. And it's 10:15 a.m. So if you show up like at 11:30, you have missed some time for your test. And that is the last day of finals week, and I need time to grade your exams on that day, to post everything on BBLearn. So I make sure if you have any comments, any objection, or saying your grade wasn't fair, I have the time to show that to you, so we have that communication during the weekend. And on Monday, I'm gonna post the grades on Vandal Web. So make sure that you know of this date. I had like around 20 students that for exam 4, they emailed me 1 hour before or 1 hour after or like some days after, that they confused the day, they didn't know all that. For makeup exams, because I want to make sure that all of you guys learn, I had like several makeup exams, you see, several opportunities, but for this final exam, I cannot do that. So as I told you, if you think you may miss that date, you are welcome to take the final exam earlier, but no later than this date. Any question about that? Yes? So yes, it would be the same as your classroom. Okay, now I have several of you emailing me that what should we study. So if you study the study guides that I posted, all the extra credit assignments that I assigned to you, all the quiz and makeup quizzes solutions, and all the exams, I'm going to, after you guys are done with the makeup exams, I'm going to post all their solutions. And self-assessment quizzes at the end of each chapter from your book. If you do that, you're going to get an A, no doubt. And to kind of like give you more opportunities and encourage you, if you just study, all the exams and their solutions, makeup exams, quizzes, their solutions, and extra credit assignments and self-assessment quizzes, you're going to at least get a B. So I'm going to use the same questions, but I just change the numbers. I will change the numbers, or like change the order of the question. So you don't see the exact same question, but if you know the answer, for sure you can answer the questions in your test. Any questions about these? Are we clear what should be studied? And then the exam is from chapters 1 to 10. Clear? Yes?
Will we be posting a chapter 10 study guide?
Yes. After we are done with the chapter 10, I'm going to post a study guide for that one too. Yes. Any other questions? Okay. And, I structured makeup exams so you take them 1 week before your Thanksgiving break or 1 week after. But there are, like, as you know, some of you are still taking them, and then you told me that the hours don't work for them. To be fair towards all students, I told you guys, anyone who wants to retake them, you are welcome to. So for that matter, I still didn't post the solutions. And that's why I didn't give back the solutions to you, because I'm reusing them. But as I said, I'm going to post the solutions, and you are welcome to stop by my office hours, see your exams, and at Friday, after the class, you are welcome to just come to my office and take them, because we'll be done with the makeup exams. Or like few of you that are still taking them, I'm using makeup exam. So I'll make sure that all of you have your solutions. Does that make sense? And as I said, I uploaded all of you that you took your makeup exam so far. You should be able to see your grades in BBLearn. If you don't see them, that's because they have been lower. But you are welcome to stop by my office hours and see your exams. And something else that I just want to encourage you. I mean, it's kind of like goes without saying, but when you show up for an exam, you should study for that exam. I realize some of you had like lower grades in your makeup exams, or like really similar grades to your original score. And that tells me that probably you didn't study well, because for instance, for chapter 1, I posted like 6 pages of Word document. And then if you would study those, just read them once, you know, there would no way for you to get like 50 on exam 1, for instance. So again, you know, make sure to study before showing up for a makeup exam. Otherwise, it just like takes my time, your time, you know, it takes, you know, instead of me grading, you know, quizzes and do other things, I have to proctor exams, grade them, takes lots of time for no reason. Okay, everything's clear? Yes?
So you know how these extra credit quizzes, if we reopen those to take them again, is it going to mess with the grade book to like study them?
Not really, no.
Okay. I just wanted to make sure it wasn't like that.
Okay, I mean when you, and I saw some of you, you didn't press OK at the end, so I cannot see your grade, probably you cannot see your grade, and you should open it, and then kind of, I should, you know, grade them like open them and then see how many questions you got. So if you can just press OK to see your grade, you know, that would be great. But, you know, if you saw that your, you know, exam score was messed up, just like email me, you know, so I make sure that, you know, nothing.
Is there like after you take the quiz to like go back in and see the answers to study them?
What's that?
So you know how like after you take these, like immediately after you see the answers?
So I didn't do that to see the, you know, answers, so I can like give extensions to students, but I'm going to post the solutions on Friday at 5 p.m. So yeah, I didn't, you know, do that feature specifically, because if you would see the question, because I wanted you guys to do that unlimited, so even if you got 7, you still can get 10, but if you see the solution, that defeat that purpose that I had. But I'm going to post all solutions at Friday at 5 p.m. and that brings up a really good point, that if you didn't do extra credit assignments, I highly encourage you to do that, because there are like lots of free points. Why not to do them, right? If you get a C, you can get a B with just doing extra credit assignments. So I highly encourage everyone to do those, and I'm going to post all the solutions. So if you went to the website, you know, on like Friday at 5 p.m. and you couldn't see solution to anything that you have taken, like makeup exam, quiz, extra credit assignments, just email me so I make sure that they are all uploaded. As I said, I believe everyone should see the solutions. I'm not reusing any of exams or quizzes. I just want you all to learn and have the solutions. Good? Okay, so now that we're done with these announcements, I'm going to go back and continue chapter 10. So we talked about Lewis models. Specifically, section 10.2 was representing valence electrons with dots. So can anyone tell me what are valence electrons? Yes?
Electrons on that outer shell.
Yes. So we have like electrons at the outermost shell. So when I give you like an electronic structures like 1s2, 2s2, 2p6, 3s2, can anyone tell me what element is this electron configuration correspond to, or does correspond to? What is this element? Which one? So how did you say that? Exactly. So you count, you know, what numbers here are number of electrons? Are they subscripts, coefficients? What are they? Superscripts, right? These numbers that we see here are number of electrons, or like there are electrons, right? So you go count, you know, add these ones, 2 plus 2 plus 6 plus 2. So it would be 12. And then you go to your periodic table, search for an element that has 12 number of electrons, meaning 12 protons means 12, they have atomic number of 12. And then you say that corresponds to Mg. What about this one? 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. What's that? How did you say that? How did you say that? How did you find the answer?
You look at the 3D box.
Okay. Yes?
Isn't that wrong?
Yes. So you see, you should pay attention, so it can be tempting to just count the number of electrons. And this is, something that I realized for most of you in this course. Like for exam 4, I realized, I thought the exam was easy, right? How many thought that exam 4 was easy? Not difficult, right? It was a reasonable exam. I just, I tried to, work through it with you guys. But I realized some of you made mistakes because you didn't pay attention to the question. You didn't read the question well. So remember, in multiple choice question, read the question well, read all 4 answers. Even if you're sure A is the answer, read the rest. Because sometimes you realize, we have 2 right answers. Why is that? And then you read the question again, you realize that I'm asking what is not whatever I asked, right? So here, do you remember, can anyone tell me, how would I fill orbitals? What is the order? So the first one is 1s. What is the next one? What is the next one? What is the next one? And next? What is the next one? What is the next one? So, if you remember this, you realize that here, we don't have 4s. That's not possible, right? Because 4s has lower energy, and that was the exception, remember? So you should first fill out 4s. So if I, I will give you in your final exam one electronic configuration and say what element does this correspond to. And you should first make sure that they are filled out, they are the order is right. I may also give you 1s, 2s, 2p, 2d. So that would be wrong, right? So pay attention, read the question carefully, and then answer to the question. Anyway, so is this clear? Is everyone comfortable with electron configurations, counting the electrons? So in D subshell, how many orbitals do we have? In D subshell, remember 1, S subshell, P subshell, right? So in D subshell, how many electrons do we have? 10. So how many orbitals?
5.
Right? So anything that is number of orbitals, you multiply that by 2, that would be maximum number of electrons. So now, let me go to this chapter, what I was teaching. So in Lewis model, we just deal with valence electrons. And as you remember, if I have for instance, carbon, and I want to write electron configuration, I go to the periodic table, I see the atomic number is 6, I write 1s2, 2s2, 2p2, right? Is that correct? Okay. So now, what are the number of valence electrons? 4, right? Is that clear why? You just look at the numbers, coefficients here, right? If we call them the coefficients, or the numbers that we write by the letter. And then we see the largest one, that is n equal 2. And then we count the number of electrons, anything that corresponds to n equal 2. So we say 2 plus 2 equals 4 valence electrons. How many core electrons do I have? So anything that is remaining would be core electrons. that we're not specifically interested in while writing, Lewis structures. So now for carbon, we have 4 valence electrons. Again, remember, we just work with valence electrons, not core electrons, not the total number of electrons. And does anyone know why we are so much interested in valence electrons?
Because it's not the highest.
Yes, so what characteristic, what does it lead to that they have like higher energy? Yes.
They're the ones used in reactions.
Exactly. So if you have like chemical bonds, these valence electrons are the ones that create bonds, chemical bonds, ionic bonds. Do you remember from the previous lecture? So can anyone tell me what is an ionic bond?
Where they transfer electrons.
Exactly. So you have sodium, you have chlorine, and sodium loses 1 electron, chlorine gains 1 electron, and you remember that we would call Cl minus chloride, right? And then the metal would be just the metal, sodium. But if it was like the metals that they would have multiple charges, we would also write the charge in Roman numerals, like iron 3 or iron 2, remember? But for group 1 and 2, and aluminum, for instance, or like silver, zinc, we wouldn't write that because they had only 1 charge, right? Remember these things from chapter 5? Anyway, so we write carbon here, and as we said, valence electrons are really important, and in Lewis model, when we want to write Lewis structures, we put like 4 electrons around the atom. So 1, 2, 3, 4. Again, we do them like Hans' rule. We just put them on sides of the atom singly first. Any question about that? So let's do for fluorine. So we go to the periodic table, and then we see that fluorine F has 9 electrons. So 1s2, 2s2, 2p. So if I put 6 here, it would be 10, so I put 1 less, right? And then I count the number of electrons here would be 7. So here I put like F. I guess I just like erase it here. So 1, 2, 3, 4, 5, 6, 7. Or like, here you can put like 2 here to be like more neat, but doesn't matter. However you put it, that's fine. Is this clear how we do this? And as we said, the Lewis model, Lewis structures are really easy. And I gave you in the homework problem too that they're really complicated models. They're not. So if I tell you they're really complicated, that statement is false because they're fairly easy. And so any questions? Yes?
So why would you do 7 dots instead of 9 dots?
So 9 dots are like the total number of electrons. Remember, we just deal with valence electrons, which are like 7. And now let's do one more example. If I do for like nitrogen, which is like the atomic number is 7. I say 1s2, 2s2, 2p, how many? 3. Is that clear? We count 2 and 2 are 4. I should have 7 total, so 7 minus 4 would be 3, right? So now here, we're dealing with 5 electrons. Any questions? Is this clear? Any questions? Okay. So we put 1, 2, 3, 4, 5. And as I said, it doesn't matter where you pair them. When we're going to write the chemical bonds and draw them, I tell you where to write them, but as of right now, it doesn't matter. So now, nitrogen is in group 5A, right? That has 5 valence electrons. Carbon is in group 4A, has like 4 valence electrons. Fluorine, where did we do that? Here, is in group 7A. It has 7 valence electrons. And do you see a trend? What is it? So nitrogen is in group 5A, has 5 valence electrons. Fluorine has 7 electrons, is in group 7A. Carbon is in group 4A, has 4 valence electrons. So as you can see, this is how we named these groups based on their valence electrons, and that's why halogens are like the same family. They have similar properties. Or noble gases, they're not reactive. They have similar properties, and they are like in the same group, in group 8A, and they have like their valence electrons, their valence shell is filled. That's why they're not reactive. So remember, if I ask you on the exam that how many valence electrons bromine has, or like, you know, oxygen has, you can just look at your periodic table, see what group they are in, right? And then that helps you when you're, you know, want to write like covalent bonds or like draw them, and like ionic bonds and so on and so forth. Is this clear how we do these things? Right? Okay. Now, let me go back to the page I was. Okay. So now, let's do a couple more examples. Okay. So for instance, neon. Again, neon is in group 8A. And if you look at it, it has like 10 electrons overall. So 1s2, 2s2, 2p6, right? And then it had like 8 valence electrons. Which corresponds to 8A. And then if you want to, you know, put the electrons around it with dots, we have 1, 2, 3, 4, 5, 6, 7, 8. Right? Any question? Is it clear how we do these things? Okay. So now, can anyone tell me what was octet? Yes? Exactly. So, you know, the noble gases, they have 8 valence electrons in their outermost shell. And all elements, when they, you know, they form chemical bonds, or like, you know, chemical bonds which include ionic bonds and covalent bonds, they want to reach octet. It means that they want to also have 8 valence electrons. For instance, you know, consider sodium. If you go to the periodic table, sodium has 11 electrons. And then if you write the electronic configuration, we did that last session too, 1s2, 2s2, 2p6, 3s1, right? And then if we lose this electron, we'll be having exactly neon configuration. Is that clear to everyone that this is exactly this? So that's why you have Na plus, and it loses 1 electron to reach an octet. So the only elements that are exception to this are hydrogen, helium, and lithium. Because these elements, hydrogen has only 1 electron, and you know, do you remember that I told you that the elements, they want to reach the noble gas electron configuration before or after them. So for hydrogen, it has 1 electron, and we have like 1s1. So it cannot have 8 electrons. It can only have maximum 2 electrons. So it reaches, you know, helium electron configuration. And then the same for lithium. Let me just write this down. So for lithium, the atomic number is 3. And if we write the electron configuration, that is 1s2, 2s1, right? And then you know from chapter 5 and 6 that you have Li plus, right? When it forms an ion, because it loses this electron. So this one corresponds to Li plus. And then now this electronic configuration is for helium that has 2 electrons. Is that clear what I'm trying to get at? So we had the octet rule for all elements except hydrogen, helium, and lithium. Any questions about that? And then we call that duet because there are just 2 electrons in helium. So they want to reach a duet configuration. Okay, so now I'm going to start with today's lecture. So 10.3, Lewis structures of ionic compounds. Electrons transferred. So, do you remember that metals, we studied metals in previous chapters, specifically chapter 5, when we were dealing with naming ionic compounds. So, do metals gain electrons or lose electrons? Lose electrons or gain electrons? Metals like lithium, we just made an example. Does it lose 1 electron or gains 1 electron, or depending on what group they are, 2 electrons or 3 and so forth? Do you have metals, do you have negative charges or positive charges? What's that? Yes, right? Is that clear? So metals, they lose electrons. So let me go back to this picture that I have here. Okay. So do you remember this picture that I showed previously, that it lists all the electronic configurations for valence electrons? So you see here, for instance, for lithium, beryllium, potassium, sodium, they have 3s1. Is it easier for a metal or sodium, for instance, to gain, after 3s1, if it wants to reach the electron configuration of the next, So here, we have sodium, right? We said that all elements, they want to, when they participate in chemical bonds, they want to reach octet, right? And that is the noble gas electron configuration before them or after them. Do you think for sodium it's easier to lose this 1 electron or gain 6 more, or actually 7 more to reach argon? Which one is easier? Gaining 7 electrons or losing 1? Exactly, right? Is that clear why just losing 1 is easier to gain 7, So that's why metals, and then if you just look at the electron configuration, you can just kind of follow what I'm saying. Or here, for instance, for chlorine, if it gains 1 more electron, it reaches electron configuration of argon. But in order to reach electron configuration of neon, it should lose 5 electrons. Is it easier to gain 1 electron or lose 5 electrons? It's easier to gain 1, right? So remember, metals, they lose electrons and they gain positive charges. What do we call ions with positive charges? Cations, right? What do we call? So nonmetals, they gain electrons and they gain negative charges. What do we call ions with negative charges? Anions, right? So you see that now in chapter 10, everything that you learned is coming together. Some of it is review, some of it is new information, but I hope now everything is started making sense. Okay, now I'm just going to, oops, what did I do? Page. So as we said, we are in section 10.3, Lewis structures of ionic compounds. So for potassium, right, we have K is 19. How do you write this electron configuration? Can you tell me, and so I write it? Okay. Exactly. And remember, potassium is in the row 4. So here you should have 4. And you know that your alkali metals group 1A, they end with S1. And the valence electron is 1 because they are in group 1A. So you kind of can validate what you wrote. Is that clear what I just said? Okay. So you have just one valence electron. So you just put it here, 1. Now let's do for Cl. Again, when you go to the periodic table, you have Cl 17. And can you guys do the same? Just tell me to write this. Uh-huh. Five, right? And again, when you have periodic table, I'll give you in the exam. You check that, okay, chlorine is in group 3. It's in the row period of 3. So this number here should be 3, right? And then it's in group 7A. So you should have 7 valence electrons. 2 plus 5 is 7. So you know that you wrote it right. So for chlorine, again, we do the same, 1, 2, 3, 4, 5, 6, 7. Right? And now you learn from just what I just said, and then from chapter 5, that what type of compound potassium and chlorine elements form. Yes, what is salt? Is it molecular or acid or ionic? Ionic, right? Do you remember metal, non-metals are ionic compounds, and the only exception was like ammonium cation that wasn't metal, right? So now, so you have this potassium and chlorine, like this. So now we want to write the Lewis structures of this ionic compound. So when you want to have the elements, kind of like when you want to form bonds between them, what I advise you to do is to write the, you have the ones that have 2 dots on the sides, and then the one that has 1 electron that I'm going to just tell you momentarily what we call them, next to the, in front of the element. So what I mean is that, for potassium, I write this 1 electron near chlorine, and then for chlorine, this 1 electron, I write it somehow that it would be face to face with potassium. Does that make sense what I'm saying? So you put the duets, or like double dots on sides, and then the ones that are like just single or like 1, they put them, near in front of the other element. So they face each other. So now, as we said, the potassium, it loses an electron and became K+, right? And Cl gains this electron and it became Cl-. Is that clear? So this is how you write, the Lewis structure of ionic compounds. You write K+, and then in bracket, you write Cl-. So that would be KCl. But this is how we write the Lewis structure. And notice that now both of them reached 8 electrons in their valence. Any questions about this? So for ionic compounds, it's fairly straightforward. You can also just do these, in your head and then say, okay, potassium, it loses the electron, so I just write K plus, and then Cl, it gains an electron and then becomes Cl minus. Any question about this? Okay, let's do one more example. So if we want to write Lewis structures of MgO, so one way is to just, remember that Mg, or like go to the periodic table, see that is in like row 3, group 2A, so it should be 3s2, right? Or the other way is just like write it. So Mg, it has 12 electrons overall, 12 protons, atomic number is 12, so we write 1s2, 2s2, 2p6, and then we keep counting. Here I have 10, so 3s2. Any question about how I wrote this? And then we do the same for oxygen. And again, for oxygen, there is one way to say that, okay, oxygen is in row 2 or period 2, and then it's in group 6A. So 2, and then 6A. So 2 here, 4 here. So this should be the valence electron configuration. The other way is just write it. 1s2, 2s2, 2p, we count 4, so it should be 4 here, right? And then the valence electrons are the electrons corresponds to outermost shell. So the larger number of n here is 3, here is 2. So we have like 2 valence electrons, here we have like 6 valence electrons. But as I said, you can just say that, okay, magnesium is in group 2A, this one, oxygen is in group 6A. So they have 2 and 6 valence electrons respectively. And now for Mg, if you just want to write the Lewis structure, so you have you put 2 electrons, 1, 2. And as I said, you can put it anywhere you want. Your book wrote it like this. It doesn't matter. You can write it like this, whichever is more comfortable for you. And for covalent bonds, it's easier to just what I said, that the electrons that are not paired, you put them between the elements. But for this one, because they're gonna lose it anyway, that doesn't matter much. So here you put it however you want, but just put 2 dots. And then for oxygen, 6. 1, 2, 3, 4, 5, 6. So you remember, that alkaline earth metals, group 2A, they lose 2 electrons. That's why we have magnesium 2+, beryllium, magnesium, strontium, barium, all of them have 2+, because they lose 2 electrons. So what happens here, magnesium loses these 2 electrons, becomes magnesium 2+, give it to oxygen. And then oxygen gains those 2 electrons. It already had these ones, gains 2 more. And then becomes 2 minus. And this is the Lewis structure of MgO. And you remember when we were naming or writing, when I was telling you, write an ionic compounds that forms between magnesium and oxygen. You would go, to your memory, you would say that, okay, Mg loses 2 electrons, Mg2+, oxygen is, you refer to that table in chapter 5. You knew that, okay, it has 2 minus. And then you write Mg2O2, and these two cancel out, or just say that it would be MgO. Remember how you would do these things? Or if I ask you in the exam, write iron 3 oxide, right? You would say iron 3 oxide. Iron 3 oxide. You would say, okay, oxide is always O2 minus, and then here iron 3. So one way was to find the least common denominator. The other way is just kind of switch this. This one comes here, this one comes here. Do you remember? Or iron. So these are review of chapter 5. iron 2 oxide. You would say that, okay, oxide is always O2 minus, iron 2 is Fe2 plus, so this one would be FeO. Do you remember these things? So make sure, something that I realized from makeup exams. Almost no one knows about significant figures. Or at least the students that took makeup exams, no one got the question that I gave about significant figures right. The other thing that I realized, most students, like 90%, they don't know how to name acids. They were like, it was the most number of questions that the students got wrong. So if you, don't remember what was acid, or how do you name them, or like ionic compound, just, email me, and then I set up a meeting for you, just explain them to you. I know that it can be overwhelming to go to a previous lecture that you missed, or like, so just email me and I explain that to you. Anything that you're struggling with. Just don't let, your grade would be lower in the test because something that you could have easily learned in like 10 minutes, okay? Anyway, so this was this. So now, is this clear how we have like loose structures of ionic compounds? So just write them for the elements, and based on chapter 5, it should be straightforward that, okay, oxygen gains 2 electrons, or like group 1A, alkali metals, they lose 1 electrons, or like oxygen gains 2 electrons. I said it right? Sometimes I say something, I mean something else. Anyway, so now this is this. Now, what we're going to do, and your book also gave an example for, other ionic compounds. For instance, what about Na and S? So this is again chapter 5. What is an ionic compound that forms between sodium and sulfur? Anyone? So we just talked about oxygen. Oxygen and sulfur are in the same group. So if oxygen gains 2 electrons, sulfur also gains 2 electrons, right? Because they have the same electron configuration. So we have S, it becomes S2 minus. Is that clear? It's also in that table again in chapter 5 that you had to memorize. Let me just write the table because that's going to haunt us. Okay, table 5, 6. Some common anions. F minus, Cl minus, and we call that fluoride. And then chloride, I guess I just write this. Fluoride, chloride. So if I say, what is, okay. So for instance, HCl. What is this acid? Do you remember how to name that? Exactly. You have 2 elements, so this is a binary acid. And then for this, you would say, hydrochloric acid, right? Or if I say NaCl, what is the name of this ionic compound? Sodium chloride, right? So you have like the name of metal, base name of non-metal plus ide. So we call Cl minus chloride. And then let me write the rest too. So Br minus is, can anyone tell me the name of this ion? Bromide, right? And then I minus, what is the name of this? Iodide. What about O2 minus? Oxide, right? You have base name of non-metal plus IDE. And then S2 minus, what is that? Sulfide, yes. And then N3 minus, nitride, right? And then you remember you had the table of polyatomic ions that I'm going to give you in your final exam. And you had also nitrite and nitrate, right? So if I tell you to write, potassium nitride, I'm referring to N3 minus, right? As long as you you know the rule and pay attention in the exam, don't get confused with nitrite, nitrate, nitride. Just like know the rules and just read the question though. Anyway, so again, so remember this table because that's, would come really handy here. So if I tell you what is ionic compound between sodium and sulfur, now can anyone tell me what ion sodium forms? Anion or cation? Cation, right? Can anyone tell me what is a cation? It's a metal, so sodium as itself is not a cation, right? It's the metal that have lost electrons, right? So this one would be Na plus. This is a cation. What about sulfur? Does it gain electrons or lose electrons? Lose or gain? It gains, right? And then I just wrote here, it gains 2 electrons. So it became S2 minus. So now you know that the ionic compound would be, so I should have 2 of sodium in order to have, here I have like the charge of 2 minus, here I should have 2 plus, right? So I should have 2 of sodium and 1 of sulfur. Or as I said, you can just put 2 here, 1 here, and then we don't write 1. So we would be having Na2S. Now we want to write Lewis structure. So for Na, this is why it's good to know chapter 5 because it comes really handy here. Now you know that you should have 2 Na and 1 S. So Na as itself, as I said, you can just write the electron configuration or just look at your periodic table. Say that it's in period or row 3 and it is in group 1A, so it has 1 valence electron. And the same thing for S, sulfur. You can look and say, okay, sulfur is in period or row 3 and it's in the group 6A, so it should have 6 valence electrons, right? Or, you can just write the electron configuration. So S is 16, 1s2, 2s2, 2p6, and then you keep counting. Here you have 10, right? 3s2, here you have 12, and then here you have 16, right? So this would be the same thing that I wrote here, right? So now, for Na itself, you just have like 1 electron, right? And then for S, you have 6. 1, 2, 3, 4, 5, 6. Is that clear how I wrote this? And now, based on what I told you, you know that you should have 2 Na, right? So 1 electron comes here. 1 electron comes here. So now, sulfur has an octet. It has 8 electrons. So, and then these two guys, these 2 sodiums, they lost their electrons. So you have Na plus, and you write the anion in parentheses, or like brackets, sorry, because you want to say it had gained 2 electrons. And then you write 2, 2, 2, 2, and then Na plus. Is that clear how we did this? Good? Okay, so I'm going to post the extra credit assignments like later today, so have an eye for it and make sure to answer those questions before the class on Friday, and I see you on Friday. Okay. Yeah. So I just make sure I'm going to my office just right after this. Yeah. I'll be there at 12:30 or 35. Yeah. Okay. Thank you. Yes. Yes. Can you also email me so I put that in on my calendar?
Can do. Thank you.
Before he said he already received it from the other professors that I was doing the makeup lab with. And so he was asking me for a lab report that he said was already graded, and I've already seen him graded.
Oh. I'll send him an email and then ask him about this and then get back to you.
So, like, the reason why I remember him